You've probably seen it a million times in movies, right? A volcano erupts and someone yells, "Look at the lava!" But then you hear scientists talking about magma. So what's the deal? Is it the same thing? Is one of them wrong? Well, stick around because after this, I promise you'll never get them mixed up again. So let's just ask it straight up. Magma and lava, are they just two different words for the same fiery, gooey stuff? Or is there a real difference? The answer is yes, they are different. And the best part is, the difference comes down to one super simple thing. Location, location, location. All right, to really get this, our story has to start in a pretty dramatic place. We're not going to start on the slopes of a volcano. No, we have to go deep, deep inside the Earth. And down there, in the dark, that's where we find magma. The official definition is actually pretty simple. Magma is just super hot, molten rock that exists beneath the Earth's surface. We're talking about it just kind of simmering away in places like the planet's mantle or the lower crust. But here's where it gets really interesting. Magma isn't just plain old melted rock. Oh no. It's more like a complex, fiery cocktail. You've got the melted rock, sure, but it's also packed with dissolved gases. Think water vapor and carbon dioxide. And it's got all these little crystals and minerals just floating around it. And when I say hot, I mean it's almost hard to wrap your head around how hot it is. Magma can easily get over 1,300 degrees Fahrenheit. It is a substance with some serious, serious power. But, the temperature is only half the story. The other really crucial ingredient here is pressure. Because it's trapped so far underground, magma is under an absolutely insane amount of pressure. The best way to picture it, think about a bottle of soda that you've shaken up like crazy. The cap is still on, but all that fizzy energy is just dying to get out. That's magma. So what happens when all that pressure finally finds a way to escape? Well, that brings us to the next chapter in our story, the Great Escape to the Surface. This whole journey starts when big pools of magma actually become less dense, lighter than the solid rock that's all around them. And because of that, just like a hot air balloon, the magma slowly but surely starts to rise, forcing its way up through any crack or weakness it can find in the Earth's crust. It just keeps pushing its way upwards, closer and closer, until finally, it finds an exit. And the exact moment it bursts through the surface, the second it erupts from a volcano, everything changes. It even gets a brand new name. And that name, as you've probably guessed, is lava. So what is lava? It's simply molten rock that has made it to the Earth's surface. It's literally the exact same stuff magma was made of. It just crossed that one critical line from being underground to being above ground. So let's just lock this in right now. If it's underground, it's magma. The moment it's on the surface, it's lava. That's it. That's the entire secret. Simple, right? Okay, now that we know the golden rule, let's put these two side by side. It'll really help to see all the differences in one spot. Let's just break it down. Location, magma is underground, lava is on the surface. What about pressure? Well, magma is under extreme pressure, but with lava, all that pressure has been released. And that directly leads to the next point, gases. In magma, those gases are trapped, but in lava, they're finally free to escape. Okay, so this brings up a really good question. If it's basically the same material, why does it act so differently? I mean, why are some volcanic eruptions these massive, violent explosions, while others are just these slow, creeping flows of rock? And the answer? It all comes back to that shaken soda bottle. It is all about the pressure. When magma erupts and becomes lava, that pressure is just gone instantly. All those gases that were trapped inside expand and burst out, and that violent release is what can cause those truly spectacular explosive eruptions. Here's another amazing analogy to make it really stick. Think about toothpaste inside the tube. It's contained, it's under a little bit of pressure, that's your magma. But the moment you squeeze it out and it's flowing onto your toothbrush, that's your lava. Same stuff, just a new location and a new name. So, okay, this is a fun fact to know, and you can definitely win a trivia night with it. But beyond that, why does this simple difference actually matter in the real world? Well, it turns out it's incredibly important for both science and for human safety. So, if you only take one thing away from this whole explainer, let it be this super simple rule. Below the surface, we call it magma. Above the surface, we call it lava. And this isn't just about getting the words right. By understanding the properties of the magma deep underground, like how much gas is trapped inside it, scientists can actually start to predict how that lava might behave when it finally erupts. And that knowledge, It is absolutely critical for studying volcanoes and protecting the people who live right in their shadow. So I'll just leave you with this one final thought. Every single river of lava that we see flowing on the surface, it's like a direct message from a hidden world deep below our feet. It's a real physical sample of a place we can never visit. So it really makes you wonder, right? What else can the lava we see up here tell us about that secret world of magma still waiting down below?